So let us solve the questions now. Practice questions. So just we will discuss these questions wherever is possible. We will take wherever possible. You can solve the questions. Welcome back. Anybody is live? Okay. Chalo, fatafat. You see this first question. A sharing bridge is shown in the figure given below. R3 is 500 ohms. So this R3 is given as 500 ohms. And C2 is 2 microfarads. C4 is 1 microfarad. R4 is 1000 ohms. The dissipation factor of branch PS will be dash. He is asking the PS. So dissipation factor के लिए आपको ये दोनों component चाहिए. C1 R1 चाहिए. Okay. So dissipation factor, how to answer this question. So methodology I will tell, dear students, methodology I will tell you, try the answer. Okay. Dissipation factor is nothing but 1 by Q. Okay, so that is 1 by 1, Q is equal to 1 by omega CR, so that will be omega C1 R1. So first of all we have to find out C1, we have to find out R1. So which method we can use? Z1 Z4 is equal to Z2 Z3 method we can use. Okay, so what is Z1? You can substitute here. What is Z1? Z1 is equal to 1 by J omega C1 plus R1. Why? Because both are in series. Both are in series. So it will be 1 plus J omega R1 C1 by J omega C1. Chalo, next. That is a PS, Z1. Z4 is R4 parallel to 1 by J omega C4. So R4 into 1 by J omega C4 by 1 plus R4 plus 1 by J omega C4. That means 1 by R4 by, so this will be R4 by 1 plus J omega C4 R4. Am I right? Anybody is there in the class live session? Please like the session and try to solve the questions. Okay, we are taking the practice test for you only. Chalo. Try to answer. So 1 plus J omega C for R4. Next. Z1, Z4. What about Z2? So this is a Z2. So this is a Z2, that is 1 by J omega C2. Next. This is a Z3, that is R3. Okay. Chalo, fatafat. We'll solve. Z1 into Z4 is equal to Z2 into Z3. So Z1 is this, that is 1 plus J omega R1 C1 divided by, this is J omega C1, and Z4, this is R4 by 1 plus J omega R4 C4. Z1 into Z4 equal to Z2 into Z3. So that is Z2 1 by j omega C2 Z3 is R3. So this is R3. So if you simplify, what you are going to get it? We check, this is 1 plus j omega R1 C1 into R4. This is R3, the whole divided by j omega C1 1 plus j omega R4 to C4. This is j omega C2. So 1 j omega gets cancelled here. Okay. So continue. This will be 1 plus j omega R 1 plus j omega R1 C1 R4 R1 C1 to R4 into C2 comes here is equal to this one R3 into C1 R3 into C1 1 plus j omega R4 C4 R4 C4. If we just R4 C2 plus j omega R1 C1 R4 C2, next this is R3 C1 j omega R3 R4 C1 C4. So compare real and imaginary. So R4 C2 is equal to R3 C1. So we need the C1. C1 is equal to R4 by R3 into C2. That's it. Next, j omega R1 C1 R4 C2 j omega R3 R4 C1 C4. So here j omega gets cancelled. C1 gets cancelled. R4 gets cancelled. Small r1 is equal to R3 C4 by C2. So first find out R3 कितना दिया है क्वेश्चन में. So R3 is how much? 500 ohms. R3 is 500 ohms. This is 500 into C4. What is the value of C4? C4 is 1 microfarad. This is 1 microfarad. 1 into 10 power minus 6. Next, what is C2? It is 2 microfarads. This is 2 into 10 power minus 6. So it gets cancelled. This is 250 ohms. Next, this one. What is R4, R3? We check R4 1000, R3 500. R4 1000, R3 500 into C2. C2 is equal to 2 into 10 power minus 6. So 4 microfarads. So we got C1 R1. So what is the dissipation factor is asked? Omega C1 R1. Okay. So omega is C1 value we got as C1 has more 4 microfarads. This is 4 microfarads. R1 has 250 ohms. So dissipation factor will be omega C1 R1. So 2 pi f C1 R1. Simplify and tell me the answer. Anybody is there in the live? Nobody is in the live, huh? आंसर बताओ भैया. So how much we are going to get? Check it. 2 into 3.14 into frequency 1000 into C1 4 into 10 power minus 6 into R1 small r1, that is 250, is coming around 6.28. Yes, the first question answer is 6.28. This is the answer. Chalo, let us go for the next question. Which of the following defines the bridge sensitivity of a Wheatstone bridge? So all of you know that Wheatstone bridge can be written like this. So if you take this as resistance R, this is resistance R, this is resistance R, this is resistance R. So this is R plus delta R, this is R, this is R, and this is our supply voltage Vs. Okay, and this is our V bridge. So we have already derived the quarter bridge expression. The bridge output voltage is equal to Vs by 4 into delta R by R. So from this we can write V bridge by delta R is a sensitivity. Okay, just which of the following defines the bridge sensitivity of a Wheatstone bridge? V bridge by change in deflection comes because of, if you take this as delta R by R, then this will become Vs by 4. Actually delta T by delta R होना चाहिए. Option both are same. Both options given same here. Actually both options are given same, so we can take actually just to mention this delta theta means output. So what we can do here, actually it should be, if you take this as a deflection, delta theta output, delta theta by delta R should be there. Delta theta by delta R should be there. So please make a note of correction. So if you take this output as deflection, this output should be mentioned there actually, delta theta. So this Vs by 4 into delta R by R. So this is a delta theta by delta R is Vs by 4 into R. So this can be taken as the sensitivity. So option A is the right answer. Please make this R out. Okay, please take this R out. Okay, to take this as a deflection delta theta, please make corrections. Okay, these corrections will be rectified. Maybe that is because of some problem in the SME. They may be hurry. Nowadays they are very busy. So in that there may be small typographical mistake. Excuse me for that. Actually we have to correct it, but before itself, S is equal to delta theta by delta R. Chalo, let us go for the next question. Next, this question how to solve. If the deflection of the galvanometer in the bridge circuit shown in the figure is 0, so this deflection is 0, then the value of Rx, so Rx is, this is Rx I think, so this the Rx in ohms is asking. So I think first of all this delta is there na, so this delta you have to connect into star model. So first try to do that. So this is how to do it. So this delta part, this is 120. Okay, so this is 250 and this is 120. Please convert this delta to star. So here x, y, z, if you take what is x? X is equal to 120 into 250 divided by 120 plus 120 plus 250. Next, y is equal to 120 into 120 divided by 120 plus 120 plus 250. Next, z 120 into 250 divided by 120 plus 120 plus 250. How much we are going to get? 120 into 250 divided by 120 plus 250 plus 120. It's coming around 61.22. Next, this is 120 into 120 divided by 120 plus 120 plus 250. It's coming as 29.38. Next, 120 into 250 divided by 120 plus 120 plus 250 is coming 61.22. Both are same, same. Chalo, now if you replace the circuit, that means you take here, this is x, this is y, this is z, how it will be? Okay, so if you take this terminal, so now the circuit will become like this. The circuit will change. Okay, so the circuit will change. So this has 120 and x will be coming in series. 120 and x will be coming here. Next, here comes the z. Next, this is 120. Galvanometer. This is Rx. Okay, now we can find it out. So this is 61.22, this is 61.22 and z is 61.22. Rx we have to, okay, so 120 plus 61.22 into Rx is equal to 120 into 61.22. So 120 into 61.22 divided by 181.2, coming as how much? 40.5. Check with the answers. Please verify your answers, okay? If any mistakes are there, let me know. So how much you are coming? It is coming around 40 change. Yes, 40 change. So Rx 40.538. Rx is coming as 40.538. That's it. So let us go for the next question. If the resistance of the galvanometer in the bridge circuit shown in the figure is 5 ohms, so this resistance is 5 ohms. Then the current through the galvanometer, again the same method. So first we have to find out this resistance. This is 50, this is 50, this is 50. So 50, 50, 50. So we can find out the XYZ delta to star. This is X, this is Y, this is Z, this is Y. So X is equal to 50 into 50 divided by 50 plus 50 plus 50. So 50 into 50 divided by 150 is coming around 16.66 ohms. Similarly, you do for Y also same, 16.66, it also same, 16.66. So replace the circuit. Anybody is there in the live? No one. So please do it. XYZ we got it. Then we can convert that circuit into normal circuit. Okay. So this is our X. This is our Y. This is our Z. Okay. So 50 into X comes in series. So here this is so here comes 50 X, 50 and X comes there, Y comes here, and there is a galvanometer. What is this resistance? 50. This is 50. This is 5 ohms. And what is a Y? Y is 16.66. That's fine. So Z and 80. This is our Z and this is okay. And the supply is 5 volts. Is 5 volts. The current passes here, XVB. Okay. Question asked is, what is the current passing through the galvanometer? So we have to find out the Thevenin's again. So this Y is 16.66. So the circuit can be changed as (66.66). The Z is 16.66. This is 50. this is T. So this is 5 volts. First find out the V Thevenins. Okay, so these two are in series. These two are in series. So V Thevenins we can find out V plus minus V minus, that is 5 into 66.66 divided by 66.66 plus 16.66 minus 50 by 50 plus 80. Okay, simplify this. How much we are going to get? 66.66 divided by 6.66 plus 16.66 minus 50. This is 50. This is 50. 50 divided by 130. So 0.4154 into 5 is coming 2.077. 0.07. So now we short it. R Thevenins we have to find. If we take the R Thevenins, so short prayer. Find out the R Thevenins. So R Thevenins, short this, these two are parallel. Yes, 66.66 and this 16.66 and 50 and 80, both are in parallel. So please find out these R Thevenins. Anybody is in the live? (66.66) into 16.66 divided by 66.66 plus 16.66 is coming 13.32. 13.32. This is 50 into 80 divided by 3 plus 80, coming as 30.76. Okay. It's coming around 44.089. Is coming as 44.089. So we can take it as this as V Thevenins, this as the R Thevenins, and this is our meter resistance. Okay, V Thevenins, how much we got? 2.077. So this is 2.077. R Thevenins we got as 44.089. R galvanometer is given as how much? R galvanometer is given as 5 ohms. So this is 5 ohms. So question asked is current passing through the galvanometer. Yes, question asked is current through the galvanometer. So we can find it out how much we are going to get. Milliamperes. How much we are going to get? Check it. It's 15 to 100. Mistake here. So this is 15 to 100. Adhe chustunna 15 to 100 we have to take. Not same. This is 15 to 100. Into 100 divided by 3 plus 50. Data insufficient, so we have taken data wrong. 100 into 50 divided by 150, coming around 33.33. Okay, so y 50 into let me solve again. X is equal to 50 into 100 whole divided by 50 plus 50 plus 100. So 100, 100, 200. This is 50 into 100 divided by 200, coming as 25 ohms. Next y 50 into 50 divided by 50 plus 50 plus 100. So 50 into 50 divided by 200. It's coming 12.5 ohms. Next Z 50 into 100. 50 into 100 divided by 50 plus 50 plus 100. So 50 into same. Both are same. 50 into 100 divided by 200. Okay, so we take here x values differ now. So this is 50 plus x. This is 75 ohms. Next, what is Z? Z is 25 ohms. Next, this is 50 as it is. Okay, this is as it is. What about y? 12 point. Current passes, remember that. Okay, done. So V Thevenin's is going to be changed now. V Thevenin's value calculation. Is 5 into 75 by 100 minus 50 by 130. $1.826. Okay. This R Thevenin's 25 parallel. This is 75, this is 25. So this is 75, this is 25. Next 50-80 parallel. So 75 into 25 divided by 100, 18.75. 50 into 80 divided by 30.76. 49.5. 49 change. So V Thevenin's is coming as 1.83. R Thevenin's is coming as 49.5. Gall limit resistance is 5 ohms. So what about the current? Sorry, we have forgotten this one more resistor here. That is our RY. That is also their Y resistance, that is around 12.5. 12 point. So this is in the AC/DC circuit. R is equal to 500 ohms. This should be ohms. Please make a correction. 500 ohms. C is equal to 2 microfarads. Then the bridge is so 1 plus j omega CR by R. Mistake. This is what? R into 1 plus omega C is equal to R by 1 plus j omega RC into 2R. Okay. So RR gets cancelled. Okay. R plus 1 plus j omega CR by j omega C. This is 1 plus j omega C. 1R gets cancelled. So what you are going to get? 1 plus j omega RC whole square is equal to 2R j omega C. So 1 plus j omega RC whole square is equal to 2R j omega C. Is 2R j omega C. So A square plus B square 2R j omega C, A square minus omega square C square R square is equal to 2R j omega C gets cancelled. So 1 is equal to omega square C square R square. This question asked 1 by R square C square is equal to omega square. Omega is equal to 1 by RC. So what is the data given? R is 500, C is 2 microfarads. R is 500, 2 microfarads. So 2 microfarads are picofarads. Question asked is in a kilo radians per second. What I can write, this is 1 by 1000 into 10 power minus 6. 1 by 10 power minus 3. This is goes to top 1000. So 1000 radian per second. That means 1 kilo radian per second. So the right answer goes to this question as 1. The right answer is 1. Answer is 1. Chalo, let us go for the next question. Try to solve this question. Find the excitation frequency in hertz and the value of the resistance R. Okay. So I think the same circuit, right? Almost the same circuit. Is it the same circuit? Parallel. So I think they're same. What is the question asked? Find the excitation frequency and the value. So find out the R2 first. So this is the R2 expression. This much lengthy questions he has given. Shit. Time waste questions. What is R1, R4? 5K, 10K. So this is 5 kilo ohms. This is 10 kilo ohms divided by R4, 10K into C2. What is the C2 value? C2 is C1 is equal to 5C2 1 microfarad. C2 is equal to 1 by 5, 0.2 microfarads. So this will be 0.2 into 10 power minus 6 minus R2. Sorry, R2 common this day. R4C2 minus R3C1 here. R3 R1 R4C. R2 is equal to R1 R4 by R4C2 minus R3C1. R3 minus R3. R3 is equal to 10K. So 10 into 10 power 3 C1. What is C1? C1 is equal to microfarad. 1 into 10 power minus 6 into 1 into 10. So find out this. Find out and verify. Okay, so you are going to get the answers. So please check. Your answers are going to be matched with A. Okay, so please substitute. Your answers are going to match with. Chalo, let us go for the next question. All the same way you can solve the methodologies. See here, what is given here? A modified Wheatstone bridge is used to measure the value of load resistance RL shown in the figure. The resistance RX is varied such that the balance is obtained when the value of branch parameters as follows: RA 12.5, RB 0.5, okay, R1 given, R2 given, R3 given, RX given. And the value of RL is asking. Modified Wheatstone bridge. So if you see this, this RX is varied. Value of RL is asking. R1 into RX, R2 into R3. How much you are going to get this? Wait, this question will solve later. Second. Let us see this question first. Oven split shown in the figure is used for the measurement of impedance of steel specimen in arm AB. This is arm AB, okay. For supply frequency of 4 kHz, attains balances with test specimen. Its other parameters are as follows: R3 is equal to 100 ohms, C2 is equal to 0.5. The value of time constant arm AB 10 kHz. For source supply frequency of 4 kHz balance. This is 4 kHz. The question asked is the value of time constant in arm AB. L by R we have to find out. So we need to find the L1 R1. So first Z1, but please do like this. I'm just giving the methodology. Z1, this is r1 plus j omega l1. This is r1 plus j omega l1, and z2 is r2 parallel to 1 by j omega c2. So this is r2 by 1 plus j omega r2 c2. So please find out that. Next z3 r3. Next z4 is equal to 1 by j omega c4. Okay, so first make this calculation. So find out this like this: z1 z4 is equal to z2 z3. So find out the L1 and R1. So time constant is equal to L1 by R1. That's it. So in that methodology you find it. I am not explaining, so you can go through with that methodology. So time constant is coming as 0.27. Okay, so you can get it as 0.27. Please find out. Chalo, let us go for the next question. So this is also same for the balance bit shown in the below. The value of inductive part in branch AB, this one, in terms of the other connected branch parameters will be dash. Okay, same. So we can find out by using these expressions. Z1 is equal to R1 plus j omega L1. This is R2, Z2 is equal to R2, Z3 is equal to R3, Z4 is equal to R4, Z4 is equal to R4 plus 1 by j omega C4. So what you can do now here, Z1, Z4 is equal to Z2, Z3, calculate it, then real and imaginary, if you imagine, so then you are going to get the inductance terminology L1. So direct balance equation. So from that you are going to get the option C. C is going to be the right answer. You can solve this R2, R3, C4 by 1. It is going to come as R2, R3, C4 divided by 1 plus omega square C4 square R4 square. Chalo. Now let us go for the next question. Chalo. Let us go for the next question. This question. A balanced bridge shown in the figure has unknown value of coil attached in the arm. The parameters in other resistance R2, R3, R4, C4. The storage factor, the value of storage factor is asking. Q is equal to omega L by R1 is asking. So how to do this? So same methodology. So first to find out the Z1. So this is Z1. This R1 plus j omega L1. This is R1 plus j omega L1. Z2, R2, Z3. This is R3. Z4 is a parallel combination of R4 and C4. So we can take this R4 1 by j omega C4. So R4 by 1 plus j omega R4 C4. So find out Z1, Z4 is equal to Z2, Z3. So real and imaginary compare karo. Then you are going to get the L1. Find the L1, find the R1. So Q is equal to omega L1 by R1. That is the best way of doing this problem. Okay. find out the L1 R1, and methodology is same. So if you do that, we are going to get it as 2.83. So we are going to get it as 2.83 medium Q factor. 2 point. Next, this one, Wagner earth bridge is generally used to eliminate the effect of earth capacitance, eliminating the effect of intercomponent capacitance, eliminating the effect of say electrostatic fields, shielding of the bridging elements. Actually, the right answer here is eliminating the effect of earth capacitance. Wagner's earth AC circuit. See, generally what happens now, whenever you're connecting the multiple components in a AC bridge, the outer arms, if any leakage capacitance is there, so that is going to be connected to the earth. Okay. The right answer for this is actually option A, earth capacitance. Okay, so let's go for the next question. The bridge is shown in the given below with the value of resistance arm AB is equal to resistance in arm AD, okay, and the capacitance in arm AB and AD. If the bridge is balanced, then the value of resonant frequency. So I think resonant frequency, everybody knows that. Okay, so this is the answer, 1 by R1. Why? Because omega is equal to 1 by R1 C1. So 2 pi F is equal to 1 by R1 C1. So F is equal to 1 by 2 pi RC. That's it. So option A is the right answer. Okay, that's it. So the thing that we have not discussed here is this question. This is a Wheatstone bridge question. So we can use some ratio concept of that. Okay. So this part we will discuss in our option C is coming, this one. So option C answer will be coming according to this concept of product. Actually, what is the answer? For a Wheatstone bridge, we will get R2 R3 is equal to R1 Rx. Okay. So usually we will take Rx na R2 by R3 by R1. But here we are having some extra component, so we have to attach those components also. So this part we will discuss in our class. Okay. So the right answer is coming as 26 ohms. This I will explain with some network concept. I will explain in the later classes. Okay. Chalo my dear, that's it. That is the end of this session. Please practice these questions. If anybody is facing any problem, you can answer me. Chalo, thank you.